Hello gems, welcome back to another video. In this video we'll be discussing all the vector knowledge that you'll ever need for physics. So in the previous video we discussed about all the maths that you'll ever need for physics. So there we discussed about integration, differentiation, trigonometry and so on. Okay, so this is a short part which is remaining. So we'll be discussing that in today's class. If you want to check out the maths video, the links are available in the description box of this video. So with that being said, let's begin with vectors. In our discussion on vectors with some basic points, first of all we'll define scalars, then we'll define vectors, we'll study their notation, and we'll also study the representation of a vector, and finally learn how to find angle between the two vectors. Okay, so let's begin by defining a scalar. So scalars are basically physical quantities that can be completely specified by their magnitude. Okay, so physical quantities are quantities that can be measured, right, and have some physical significance. Okay, so we learned this in units and dimensions, right? So you can take the example of mass, volume, distance, and you can add more to the list. Also charge is a scalar, okay, although it is minus and plus, but it is a scalar. Okay, it can be completely specified by its magnitude. Okay, you can take the example of mass, 10 kgs, right? So 10 kg is some amount of matter, some amount of mass, right? So it can be completely specified by that value, 10. Okay, 10 kgs. Okay, so yeah, scalars are physical quantities completely specified by magnitude. Okay, so in case of vectors, they are physical quantities for which you need both. Okay, you'll also need the direction and the magnitude to completely specify it. Okay, so for vectors you need both direction and the magnitude in order to specify it. Examples are displacement, velocity, force and so on. Okay, acceleration also. Okay, so basically you can take the example of displacement. Displacement is a vector, so it will be different in this direction and this direction. Okay, so basically if I move 2 units from here, okay, it's different from 2 units from here, right? So displacement is a vector. Okay, displacement has a particular direction. You need to specify the direction. 2 units on the left hand side, 2 units on the right hand side. Okay, so those are vectors. Okay, you need the magnitude as well as the direction. Velocity 1 meters per second, in what direction? Okay, in the northward direction. Okay, whatever. Okay, so you need to specify both the magnitude and the direction for your vector. Okay, now coming to the notation, usually in the books they'll use, in your reference books they'll use bold letters for your vectors. Okay, but we cannot every time highlight like this, so for our convenience we use this letters with a bar. Okay, so we usually use capital letters with a bar. So if you want to show a vector, okay, you will show it this way, a with a bar on top. Okay, some of them also put a arrow instead of bar. Whatever, you can use a arrow or a bar. Okay, so this is the way you show a vector, arrow or bar. Okay, so if you want to show torque vector, the letter for torque is tau, and you'll put a bar on top or an arrow on top. Okay, whatever. Then coming to the representation, a vector is represented by an arrow. Okay, this part of the arrow is called a tail. Okay, it's the end part, and this is the forward part, which is the head. Okay, so basically a vector is represented by an arrow. Okay, and this arrow is such that its length is proportional to the magnitude. Okay, so you will choose a particular scale. Suppose you want to represent a vector, velocity vector of 2 meters per second. Okay, and which is in the this direction, positive x-axis. Okay, so this is the direction of positive x-axis, and it is 2 meters per second. Okay, and you'll choose a particular scale. Suppose this is 2 centimeters. Suppose, okay, suppose this is 2 centimeters. So you'll say 1 centimeter is equal to 1 meters per second. Okay, you'll choose a particular scale. So this is 2 centimeters, so it will be 2 meters per second. So 2 meters per second, and the head will show the direction of your vector. Okay, so this is how it's represented. Okay, so a vector is represented, what am I saying, by an arrow such that its length is proportional to the magnitude, and the head shows the direction of the vector. Okay, coming finally to the angle between two vectors, it's very simple. You just have to keep in mind one thing, that both the tails of both the vectors should be aligned. Okay, so you need to combine the tails. So if you want to measure the angle between two vectors, first bring their tails together. In your case, we discuss about delocalized vectors, so you can move the vectors parallelly. Okay, so if the vectors are far, okay, like this, you can bring them parallelly so that their tails touch each other. Okay, these are delocalized vector, which are very simple discussion. Okay, so for those vectors we can bring the tails together and then measure the angle between them. Okay, so here the angle between the two vectors, let's call them A and B. The angle between these two vectors is 60 degree, clearly seen. Okay, here keep in mind that tails should be aligned in order to measure the angle. Okay, so first step is to align the tails. Okay, so first tails should be aligned. Okay, so what will you do here? Here the angle between the two vectors is not 150. Okay, you'll have to shift it. Okay, you'll have to shift this vector above. Okay, so you can see that this is a straight line, so this will be 30 degrees. What I'll do is that I'll shift this vector above. Okay, so that their tails will align. Okay, so this is the tail. Okay, so I will just shift it above. Okay, just drag it above. Okay, so that their tails meet each other. Okay, and here the angle between them will be 30 degrees. Okay, 150 plus 30 is 180. Right, so that's how I calculated that. So the angle between these two vectors is 30 degree. Okay, so in order to find the angle between the two vectors when they are represented as arrows, you can just align their tails together and look out for the angle between them. Okay, so yeah, that's from this section. Let's move to the next section. Discuss about the kinds of vectors. Here the classification is based on the magnitudes, at least for this three. Here for the fourth one, it is based on the angle between them. Okay, so in addition to this, in your reference book you'll find a lot of types of vectors like co-initial, co-terminal, coplanar, but those are not really important for you. These few are the important ones, okay, which will come every now and then in our discussion. Okay, so let's discuss about them, starting with the unit vector. Unit vector is basically a vector which has magnitude 1, okay, or unit magnitude. Okay, unit meaning 1. Okay, so basically a vector with unit magnitude. So suppose if I say the force on an object is 1 newtons along positive x-axis, it's a vector, right? I have to specify the magnitude and the direction. Okay, so 1 newton along the positive x-axis, but you can note that the magnitude is 1 newtons. Okay, it's unit. Okay, so such type of vector can be referred to as unit vector. Okay, so any vector with unit magnitude, okay, with magnitude 1. Okay, you represent the magnitude of a vector as this. Okay, a simply if you have a vector A, you will represent its magnitude by simply the letter A. Okay, this is vector A, this is the magnitude of the vector A. Vector A, magnitude, only its value. Okay, so value of the vector A, or you can also write it this way, that magnitude of vector A. Okay, here we use the mod sign, but it doesn't mean the absolute value. It's basically a notation used. So it says the value of vector A. Okay, the value of vector A, or the magnitude of vector A. Okay, so that is the notation used. When this magnitude is 1, it is a unit vector. Okay, you might have heard about I cap, j cap and k cap. These are unit vectors along your x-axis, y-axis and z-axis respectively. Okay, remember this point, we'll be using this later. So I cap, j cap and k cap are unit vectors along x-axis, y-axis and z-axis respectively. Okay, so this is along x-axis, this is along y-axis and this is along z-axis. Okay, so basically if you want to represent a point, later we'll discuss this. Okay, so just remember for the time being that I, j, k are unit vectors along x, y, z axis respectively. Okay, and finally if you want to represent, or if you want to find a unit vector, you can find using this formula. So suppose you are given a vector and you want to find its unit vector, you'll basically divide that vector by its magnitude. Okay, for the time being, remember this formula, we'll use it at the end of this class. Okay, so unit vector is given as vector divided by its magnitude. Okay, so let's comment on the second type of vector, which is zero vector. Okay, zero vector, you guessed it, it is a vector with zero magnitude. Okay, so basically a vector with zero magnitude, and since the representation of a vector is an arrow, and arrow, the length of the arrow represents the magnitude, right? But here the magnitude is 0. Okay, so its size will be 0. Okay, so you cannot really tell the direction of a zero vector. Okay, so it does not have a specific direction, no specific direction. Okay, because length is proportional to the magnitude. Here magnitude itself is 0, so that's why you cannot tell the direction of that arrow. Okay, there is no arrow. Okay, so zero vector is a vector with zero magnitude and no specific direction. Let's come to this one. Third one is equal vectors. Okay, so two vectors. Of course, in order to call two vectors, you need two vectors to call them equal, right? So of course a vector is equal to itself, but yeah, if you want to compare two vectors, then two vectors are said to be equal if they are equal in magnitude and direction. Okay, so you have to check both the aspects. Two vectors can be only called equal if they have the same magnitude and the same direction. Okay, so from here, can you tell me which pair is the one which is equal? Is it pair 1, 2 or 3? It's the pair 1, right? Here you can see that magnitude is equal, the length of the arrow is equal, which represents the magnitude. Okay, so the length of the arrow is equal and it is in the same direction. Here you can see length is equal but opposite directions, right? Okay, so here the directions are opposite, so A vector is not equal to B vector, and here also, here if you see direction is same but magnitudes are not same. Okay, so again A vector is not equal to B. Here if you see both the magnitude and the direction are equal, so A and B are equal. Finally, let's come to orthogonal vectors. Orthogonal basically means perpendicular. So if one vector is perpendicular to the other, then those two vectors are called orthogonal vectors. Okay, so A is perpendicular to B. Okay, so the angle between these two vectors is 90 degrees. Such vectors are called orthogonal vectors. Okay, so that's about the kinds of vectors which are really important for you. Let's move to the next section now. Now discuss about addition and subtraction of vectors. Okay, so this is a little bit subtle, because if you have suppose scalars, it's very simple, right? Scalars are basically physical quantities with magnitude only, right? So if you have two magnitudes, you can just add them or you can just subtract them. Okay, of course they should be of the same physical quantity. Okay, suppose you have 1 coulomb of charge and 2 coulomb of charge over here, the net charge will be 3 coulombs, right? 1 plus 2, 3. Okay, so scalars you can directly add, right? Mass also, if it's there 2 kgs plus you put some more mass like 5 kg on it, 5 plus 2, 7 kgs. Okay, so you can just add the scalars. Okay, but in case of vectors, you also have to consider the direction. Okay, you also have the magnitude and also you have the direction. So adding them is a little bit subtle. Okay, so we'll learn two laws over here, parallelogram law and the triangle law, which is just the modification of this. Okay, so here we'll be able to find, so when you add two vectors, basically you'll also, the answer will be a vector. Okay, so when you add two vectors, the answer will be a vector, and for that vector will of course have a magnitude and direction. Okay, so our objective is to find that vector, the resultant vector, when you add two vectors. Okay, so we'll find the magnitude of the resultant vector and the direction, okay, with respect to our first vector. Okay, so let's do it. Okay, let's understand it now. So the first law is parallelogram law. Okay, this will give us the resultant, the addition of two vectors. Okay, so parallelogram law states that if two vectors form the adjacent sides of a parallelogram, the key point over here is they should be aligned tail to tail. Okay, so like shown in the figure. Okay, so the tail of A coincides with the tail of B. Okay, so if two vectors form the adjacent sides of the parallelogram such that their tails coincide, the resultant is the diagonal of the parallelogram. Okay, so the resultant addition will be the diagonal of the parallelogram. Okay, so here R will be A plus B. Okay, so basically this is the resultant of adding A and B. Okay, this is the resultant, this is the resultant of adding A and B. Okay, so if you have like a rubber band, okay, you can stretch it, okay, and if you stretch it, okay, and leave it, okay, the resultant will be like this, whereas the tension was, okay, so if you have a rubber band like this, so if you pull it like this, okay, so the tension was like this, okay, the string is pulling you this way and this way, okay, and if you put an object over here, it will release in this direction. Okay, you can see that these are the two adjacent sides and this is the diagonal, right? So that is the true essence of your parallelogram law. Okay, so if you have two vectors, tension is like a force, right? Force is a vector. So you have two vectors which form the adjacent sides of a parallelogram tail to tail. Okay, the resultant will be along the diagonal of the parallelogram. Okay, so resultant is r equals a plus b, right? Resultant just adds them. Okay, the magnitude of the resultant is given by this formula, under root a square plus b square plus 2ab cos theta. Okay, a is the magnitude of a, b is the magnitude of b, yes, and cos of the theta. Theta is the angle between a and b. Okay, the angle between a and b. Okay, angle between the two vectors. Okay, now there is a derivation behind this resultant. Basically, you have to drop a perpendicular and then find cos and sin theta here and here, and then just apply Pythagoras. Okay, so yes, I've done this in one of my previous videos. You can check the analytical approach, that also I'll put up in the link. Okay, but here it's not of concern for us. Okay, we'll directly note down the formula. Okay, so the resultant, the magnitude of the resultant is given by this. Okay, when you add two vectors, you get a vector, and the magnitude of that vector is this. Okay, square root of a square plus b square plus 2ab cos theta. Okay, and tan of alpha. Alpha is the angle which the resultant makes with the first vector. The resultant makes with the first vector, vector a. Okay, so basically it is b sin theta. Here you will get basically b sin theta, and here this is a plus b cos theta. Okay, if you can imagine it. So when you drop the perpendicular, here it will be b sin theta, b sin theta. Okay, and this will be b cos theta, right? So a plus b cos theta, adjacent side. Okay, this is opposite, this is adjacent. Okay, anyways, if you don't remember, you can just by heart it. This is the important formula. This you won't usually be asked. Okay, this is the important one that you should remember. Okay, so let's discuss a few special cases that in which we'll try to find the resultant. Okay, resultant addition. Okay, so suppose theta is 0. Theta is 0 meaning the angle between the two vectors is 0. The two vectors are parallel or in the same direction. Okay, so basically r will become a plus b. Okay, so if you substitute in this formula, theta is equal to 0, cos of 0 is 1. Okay, so this term will go. Okay, so effectively the term will be like this. So a square plus b square plus 2ab. What is that? That is a plus b the whole square, and that square and the square root will cancel, and finally you will have a plus b. Or you can just imagine that when theta is 0, a and b are in the same direction. So they are like scalars. Okay, right? Because the direction is the same, you can just add them, right? And here when the angle is 180 degrees, cos of 180 is minus 1, right? Cos of 180 is minus 1. So it is a square plus b square minus 2ab, which is like a minus b the whole square. So that whole square and the square root will cancel. So you will have a minus b. Or when the angle is 180, you can see that the two vectors are opposite to each other. Okay, so this is going like this. This is going like this. The angle between them 180 degrees. Okay, right? Here and here. So angle is a straight line. Okay, 180. So basically you can subtract the two vectors, and the direction will be in the direction which is greater. Okay, so if you have like this and like this, okay, so the effective direction will be in this direction. Okay, resultant. So basically you can subtract, and the resultant will be in the direction of the bigger one. Here the resultant will be in the same direction when theta is 0. Okay, now if you have the angle between the two vectors as 90 degrees, okay, orthogonal vectors. Okay, so here, so if you have theta is 90 degrees, so basically cos of theta, cos of 90 is 0, so this term will vanish. Only you'll have under root a square plus b square, which is similar like Pythagoras, right? So this is your resultant. Okay, so basically it's a cube, so it's similar like Pythagoras. Okay, r is equal to a square plus b square. Okay, this is not that important case, but these two are important. Okay, so when you spot this type of cases, you can basically directly subtract a and b. Okay, that will be a shortcut. Okay, when you see that theta is 0, you can basically treat them as scalar, add them, and the direction will be same as their direction. Okay, the direction of a and b. Okay, so let's come to a problem now. Okay, let's solve this problem, and let's see how much we have understood. Okay, so here a, the magnitude of a force A is given as 3 newtons, magnitude of force B is given as 4 newtons, and the angle between them is 60 degrees. Okay, so here we have force A, force B. So A is 3 newtons, B is 4 newtons, angle between them 60 degrees. You are supposed to find their resultant. Okay, so construct a parallelogram like this. Okay, so you can construct a parallelogram and the resultant will be along the diagonal. Okay, so basically first find the magnitude. Okay, so magnitude will be given as, so basically here in this question we are just supposed to find the magnitude of the resultant. Okay, so a square, which is 3 square 9, b square 16 plus 2ab 2 into 3 into 4 and cos of 60. Sine of 30 half, cos of 60 half. Okay, so half, this and this will cancel. Here we'll have 9 plus 16 25 plus 3 4s are 12, that is square root of 37. Okay, so this is how you find it. Okay, problems won't be such trivial. This will be a mid step. Okay, we are going to use vectors a lot in the further chapters. Okay, so this is how we'll find the magnitude of a vector. Okay, so when we are given the magnitudes of two vectors and the angle between them, the resultant can be found this way. Okay, this is the magnitude of the resultant. You can also find the direction. Okay, you can find tan alpha and the direction will be along alpha with respect to a. Okay, but that is not that important. It's not usually asked. So that's about the parallelogram law. We have one more law, which is the triangle law, which is just the modification of this. Okay, so let's move to that. Discuss about the triangle law, which is also a modification of your parallelogram law used in addition and subtraction of vectors. Okay, so it states that if the head of one vector is placed on the tail of the other, you can see over here that head of A is placed on the tail of B. Right? This is the tail of B and this is the head of A. Okay, so head of A is placed on tail of B, then the resultant is a vector. Of course, the addition of two vectors will give a vector. So resultant will be a vector from the tail of the first to the head of the second. Okay, now it's not that hard to remember. You can remember it this way. Okay, you can picture it. Okay, so going from here to here and then from here to here is same as going from here to here. Obvious, right? So if you want to go from here to here and then from here to here, it's same as going from here to here, right? So A plus B is same as this R. Okay, you can directly go from A to that final destination. Okay, so if you want to choose a midpoint, so if you choose this route, okay, from A to here, from this to here, it is same as from this to here, right? So that is the way you can picture it and remember it. You can also see that this is just a modified version, as I was telling you, of the parallelogram law. So you can basically shift that B is over here, right? So you can shift that B over here, right? So it is just the usual parallelogram law, right? So if you have A and B, their tails aligned, the resultant will be along the diagonal. Okay, so you just have to shift that B parallelly so that their tails match. You can see the parallelogram law. Okay, so this is just a modification of your parallelogram law. Okay, and this is triangles law. Okay, so as I said, it is just a modification. Okay, and so the results will be the same. The R that you get will be again a square plus b square plus 2ab cos theta. Okay, or cos theta is the angle between A and B, the same angle. Okay, you just have to align their tails to measure their angle. Okay, this won't be the angle between A and B, this will be the angle between A and B. Right? This will be theta. Right, when you shift that over here, okay, you have to shift B parallelly so that their tails match. Okay, when you measure the angle, the tail should match. Okay, so this is not the angle between A and B. Okay, you just have to shift B parallelly. You can see that this and this angle will be same, so it's why I have written theta over there. Okay, now study the component form. Okay, so in order to understand this component form, so basically in component form what we are doing, we'll have a vector. Okay, we'll break it into two vectors. Okay, we'll reverse engineer the process we have done so far. So far we have added two vectors to get a resultant vector. Now we'll have one vector and we'll break it into two components. Okay, we'll break it into two vectors, the addition of which will give us that particular vector. Okay, so the process might seem complex, but let's simplify it. Okay, suppose we have a point like this. Okay, point 3, 2 on the in the Cartesian plane. Okay, on the x and the y axis. Okay, the point is 3, 2. Okay, so what does this mean? This means that the distance from the y axis or the intercept on your x-axis is 3 and the intercept on your y-axis is 2. Okay, so it's 3 comma 2, right? So if you want to get to this point, you can say that move 3 units on the x-axis and move 2 units on the y-axis. Okay, move 3 units on the x-axis and move 2 units on the y-axis. You can see that this is the resultant, right? This is like the triangle law, right? Move 3 units like this and 2 units like this to get to here, or you can directly go from here to here, right? So that is the idea behind this. Okay, so we are going to break this, we are going to treat a particular vector as resultant and we'll break it into two component vectors which are perpendicular to each other. Okay, so we'll break this vector into two vectors which are perpendicular to each other, and the addition of which will give us this particular vector. Okay, let's revise that again. So we'll break this particular vector into two vectors, the addition of which two vectors will give us this vectors, and of course the two vectors will be perpendicular to each other. Okay, so we can represent this entire point R as, so if you want to represent this vector, you can write as 3 I cap. You know that I cap is the unit vector along x-axis, so instead of saying that move 3 units along the x-axis, we can directly write 3 I cap, right, plus 2 j cap. So move 3 units along the x-axis. I cap will not affect the magnitude, right, because I cap has unit magnitude. So 3 times 1 is 1, sorry 3. So 3 I cap, so move 3 units along the x-axis, 2 j cap, move 2 units along the j cap axis. You reach the point 3 comma 2. So this vector can be represented, this vector can be represented as 3 I cap plus 2 j cap. Here the point to note is that 3 and 2 are scalars, right? They are particular values. Okay, and only the vector is I cap and j cap. Okay, so in 3 dimensions also you can take 3 points, and that in that case it will be moved along the x-axis some distance, then along the y-axis, and then along the z-axis. Okay, so that also can be done. So in general you can write it this way, right? So you can break a particular vector into its x component, y component, and z component. Okay, so not only this is for the position vector, right? This is for a position of point on the plane. This can be done for any vector. Okay, you can resolve any vector. This is called resolving a vector into its component, and this form of the vector is called the component form. Okay, this is the component form of the vector rx I cap plus ry j cap plus rz k cap. Okay, here rx, ry and rz are scalars. They will be numbers. Okay, and I j k are the unit vectors along x, y, and z. Okay, so basically the thing is, what we are doing over here, final aim is breaking a vector into its component rx, ry, and rz along the x, y, z axis, 3 mutually perpendicular axes. Okay, so if you have a vector, we'll break it into 3 parts. Okay, such that the 3 parts are perpendicular to each other, rx, ry, rz along the 3 axes, and their addition, okay, will give us the vector. Okay, so that is the idea behind our whole resolving of vector. Okay, and the magnitude of the vector, suppose you are given a vector in this form. Okay, let's take this vector. Okay, k cap is 0. Okay, so suppose we have this vector, and if you want to find its magnitude, you just have to square these numbers and add them. Okay, so 3 square plus 2 square, that will be 9 plus 4, that will be 30, right? Okay, so that is how you find the magnitude of a vector in component form. In component form, you just have to square the coefficients, okay, of I, j, k and add them. Okay. Now this is the logic that we are going to use to solve this question. Here we are supposed to resolve this vector of 8 newtons along x and y axis. Okay, this idea of resolving will be used a lot in Newton's laws of motion and all the upcoming chapters, so it's very important. Okay, so get this point over here. Here we have drawn this is something that we'll use in that question, so I'm briefing upon on this. Okay, so here we have a triangle ABC. Okay, and you can see that AC is R if you want the vector signs to be there. Okay, so AC is R, the resultant vector, and these are the two vectors. Okay, on adding which you get the resultant vector. Okay, so if you see here this side, the adjacent side, I have called it R cos theta, and opposite side will be r sin theta. You can show the proof for this. It's very simple. Cos theta. So if you write cos theta, theta is the angle between your resultant and your angle, this resultant and this vector. Okay, this particular first vector you can see. Okay, so cos theta. So theta is this angle. Cos theta will be adjacent upon hypotenuse, right? So adjacent is CB, hypotenuse is AC. AC is R. Okay, so let's take it to the other side. So if we take it to the other side, it will be AC cos theta. AC is R, right? So R cos theta. So CB is nothing but R cos theta. And similarly, you can prove that AB is nothing but R sin theta. It will be AB by AC sin theta, and AC you take it to the other side. So AC sin theta is AB. So AC is R, so R sin theta is AB. Okay, so this is how we are going to resolve it. Okay, so basically, if you want to break a vector R into its perpendicular components like this and like this, okay, so this side, which is opposite to theta, will be R sin theta. Opposite to theta is the R sin theta. Adjacent to theta is R cos theta. This is the point that I want you to remember. Okay, so opposite to theta, R sin theta. Adjacent to theta, R cos theta. Opposite to theta, R sin theta. Adjacent to theta, R cos theta. Okay, so here, if we want to break this 8 newtons along this and this axis, okay, you can keep the point here also. It doesn't really matter. You are just going to shift it, right? So we are shifting it. I'm showing it to you. It's actually like this, here and here. This is how we are going to resolve it. Okay, so this will be R. This is theta, right? This is theta. So this side is adjacent to theta, right? This is theta. Adjacent to theta will be R cos theta, and this side is opposite to theta, R sin theta. Okay, so you can easily split that. R is nothing but the magnitude of your resultant vector, right? So 8 sin theta, sine of 45, 8 by root 2, 1 by root 2. So that is 8 can be written as 2 root 2, I guess. It is 4 2s are. So this is root 2 into root 2, so 4 root 2. Okay, this can be written as 4 root 2. Yes, so this is 4 root 2, and also this is along the x-axis, and also along the y-axis it will be 8 of this. So basically it is 8 cos theta over here, cos of 45, and here 8 sin of 45. Okay. Sin of 45, cos of 45 is 1 by root 2. So that's how we get 4 root 2. Okay, and finally you can write the vector in the component form. This is Rx. This is Rx along the x-axis, this is Ry, and you have to put I cap and j cap, right? So this is along the x-axis and this is along the y-axis. Okay, so this is how you resolve a vector in component form. Okay, so basically, if you are given a vector and the angle it makes a particular axis, you can break it into the parallel component. Okay, and basically the two components which are perpendicular to each other, okay, which is along that axis and perpendicular to that axis. Okay, you can break that vector along the axis, okay, with which it makes the angle, and perpendicular to the axis. Along the axis r cos theta, perpendicular to the axis r sin theta. Okay, so that is how you break a vector into its components. Okay, so that's about the component form. Let's go to the final part, which is about the vector products, which is there are two types of products. One is the scalar product. So when you multiply two vectors, you can either get a scalar or a vector. Okay, so one is the scalar product, the dot product, and other is the vector product. So let's go to them. Let us now discuss about the two types of product. First one is the scalar product. So in scalar product, as the name suggests, it is a product which gives a scalar. Okay, so it's a product of two vectors which gives a scalar. It is also called dot product. Okay, so basically you represent it by a dot, so it is also called dot product. Okay, so A dot B. Okay, so it is scalar product or the dot product. So A dot B, it is defined as magnitude of A into magnitude of B into cos theta, theta being the angle between the two vectors. Okay, theta is the angle between them. So angle between A and b. Okay, so a dot b is basically magnitude of a into magnitude of b into cos theta. Okay, so that is how you define it. Now these are few properties of your dot product. So basically your dot product is commutative, so a dot b is same as b dot a, so the order does not matter. It is also distributive, so a dot b plus c is equal to, you can distribute it, a dot b plus a dot c. Okay, this is actually very mathematical, you are not going to come across this usually. Okay, but this is important, this one and this two. Okay, and this last few properties are important. So a dot a is basically a square. Okay, you can say it by the definition itself, a dot a, so magnitude of a and cos of 0, right? The angle between a and a are parallel, right? A and a are equal vectors, the angle between them will be of course 0. Okay, vector is equal to itself, right? So the angle between a and a is 0, right? They are parallel. Okay, so cos 0, and here magnitude of a, and in place of b also we are having a. Okay, so a into a square, right? So that is the property over here. And also if we have I dot I, j dot j, k dot k, so again same, it will be I square, but I has magnitude 1, right? I, j, k, these are unit vectors. Okay, so they have magnitude 1, so 1 square is 1. So I dot I, j dot j, k dot k is 1. Okay, since theta is 0. Okay, so yes, and here if you see I dot j, so if you take the dot product of two opposite, the not opposite, two perpendicular vectors, okay, that will be 0, because cos of 90 is 0, right? So I dot j or j dot k, these are perpendicular, k dot I, so all of them are perpendicular to each other, right? So that dot product will be 0. Okay, when theta is 90, cos of 90 is 0. Okay, so if you have two perpendicular vectors, the dot product is 0. So sometimes this question is usually there in maths, not in physics. So they'll give you two vectors and they'll ask you to prove that these two vectors are perpendicular, are orthogonal. Okay, so how will you prove that? You will take the dot product and show that it is equal to 0. Okay, when the dot product is 0, means that the two vectors are perpendicular, like in this case. Okay, now if you have the two vectors in component form, this is, if you see, this is vector a, this is vector b, right, in component form. Okay, so you are just supposed, if you want to find the dot product, you just multiply the corresponding xx component, yy component and zz component and add them. Okay, because this and this, if you take the dot product, I cross I dot j will be 0, right? So only the contributing ones are xx, yy and zz. Okay, the other x, y will not contribute. This x and y will not contribute, z and y will not contribute, because j dot k will be 0, so that way. Okay, so this are 0. Okay, so only the contributing ones are xx, yy and zz. Okay, so ax, bx, ay, by, az, bz, and add them. Okay, that is what we are going to do over there. And finally, if you in some questions they will ask you to find the angle between the two vectors. They will give you two vectors in component form, like in this question, and they will ask you for the angle between them. Okay, so basically if you want to find the angle, you can also find cos theta, and that will be enough. Okay, so cos theta will be a dot b upon magnitude of a and magnitude of b. So cos theta is a dot b upon magnitude of a and magnitude of b, comes from the definition itself. So here is a question, similar question asked, which asks you for the angle between the two vectors. These two vectors are given in component form, as you can see. So first of all, cos theta will be given as a dot b upon magnitude of a and magnitude of b. Okay, so let us find a dot b first. A dot b. Okay, it will be ax, bx, ay, by, az, bz. Right, here y is 0. If you see, it is like plus 0 j cap minus k cap. Right, so let's find the dot product ax, bx. So 2 into 1. Okay, then this is 1 into 0. So minus 1 plus minus 1 into, this is also minus 1. Okay, carry it with the sign. Okay, so the components, carry it with the sign. Okay, here it is plus 2 plus 1 plus plus minus minus, right? So carry it with the sign. So this is 2, this is 0, and this is 1. 2 plus 1 is 3. Okay, so this is A dot B. What will be magnitude of A? So A is given in like this. Okay, how do you find the magnitude in component form? You just square the components, right? Square the components and add them. Okay, so 2 square 4 plus 1 square 1, right? The component over here is 1, and plus minus 1 square, that is also 1. Okay, so 4 5 6 under root 6. Okay, and for B, what will be the magnitude? It is 1 square 1, 0 square 0, and here also minus 1 square 1. Okay, so it's square root of 2. Okay, so cos theta will be A dot B, which is 3 divided by square root of 6 into square root of 2, which is square root of 12. You can simplify this actually. So 12 is 4 3s are, so 2 root 3, and it will be root 3 by 2. Okay, so cos theta is root 3 by 2. So for which acute angle theta is cos root 3 by 2? Cos 30, I guess, right? So cos 30 is root 3 by 2. So from there you can make out theta. Okay, and sometimes if you have complex answers, like not complex, I mean by complex I mean complicated. Okay, so complicated answers like root 3 by 8, of which you don't know the cos. So in that case you can just express this as cos inverse of root 3 by 8. Okay, no need to further solve it, you can express it this way. But here in this case it was easily simplifiable, and when you simplify you get root 3 by 2. You know that cos 30 is root 3 by 2. So the angle between the two vectors is 30 degrees. Okay, how did we do it? A dot B, using this formula, ax bx plus ay by, just az bz, add them, and magnitude of A is square root of the component square. Okay, we learned this in the component form. Magnitude of B, similar way, and use this formula, okay, to find the angle between the two vectors. So finally let us go to vector product, and then we can end this chapter. To the second type of product, which is the vector product or the cross product, since we use a cross over here. The previous one was a scalar product or a dot product. Okay, so in this the result is a vector, so it is called vector product, and the symbol that we use is a cross, so it is cross product. Okay, so A cross B, so the result is a vector, that is what. Okay, so and this vector will be perpendicular to both A and B. Okay, so let's consider the direction fact later. Okay, so how is A cross B defined? A cross B defined as a magnitude of A into magnitude of B into sine theta, and it's not done over there. You are also supposed to specify the direction. Okay, so we use a vector n to specify the direction. Okay, this is unit vector n, which is along the direction of A cross B. Okay, so how do we find the direction of A cross B? We know to find the magnitude of A, magnitude of B, and sine of the angle between them. But what about the direction? How do you determine the direction of A cross B? Okay, so one important fact to remember about A cross B, the cross product, is that the vector, okay, the vector A cross B, okay, the resultant vector that you obtain after taking the cross product of two vectors will be perpendicular to both the vectors. Okay, both the vectors A and B. Okay, so the vector A cross B, of course the result is suppose the result is C. Okay, so suppose A cross B is equal to C. So this vector C will be perpendicular to both A and B. Okay, so now suppose we have A and B like this. Okay, so it can be perpendicular this way or perpendicular inside, right? It can come out or it can go in. Okay, so what decides that? Okay, that should be one direction, right? Okay, one particular direction to the vector. Okay, so how do we decide that? Is it outward or is it inward? Okay, suppose if the A and B are in this plane. Okay, so in order to do that, we use the right hand thumb rule. Okay, it's very simple. Okay, or the screw rule. Okay, so you can place your palm across the vector A, across the first vector, okay, A, and then rotate it to B. Okay, place it along A and then rotate it across B. Okay, rotate to B. Okay, and if your thumb is pointing out, the vector is coming out. Okay, it can be in this place or plane also. So suppose we have A in this direction and B towards you. Okay, so if we go from A to B, okay, if we go from A to B, okay, thumb is pointing upward. So our C, so A cross B will be in the upward direction. Okay, here A cross B is in the outward direction. Here in this case, if you see, if you go from A to B, okay, see my positioning of hand change, right? So A to B, the vector is inward. Okay, so similarly, so it can be in any plane. So you just have to place your palm along the first vector A and then move to B. Okay, A, then move to B and see where your thumb is going. The thumb indicates the direction of the cross product. Okay, so that is how you find the direction of the cross product. Now some important properties. So your cross product is not commutative. Your dot product was commutative. It says A dot B is B dot A, but here it is not the case. A cross B is minus B cross A. Okay, if you can imagine it, here if you see, it is A cross B. A cross B, outward direction. Here it's like B cross A. Okay, inward direction. Okay, those two directions are opposite. So that's why A cross B is minus B cross A. Here also if we take I cross I, J cross J, K cross K, here it's 0. Okay, because between I and I, J and J, K and K, the angle is 0, right? I and I along the same axis, right? Along x-axis, sine of 0, 0, right? So since the angle between them is 0, sine of 0 is 0, and I cap cross I cap or J cap cross J cap, K cap cross K cap is 0. Okay. What about this now? I, J, K. Okay, now this gives a different result. Okay, if you, I told you that the cross product will be perpendicular to the both the vectors, right? So if you take I cross J, it will give you K, right? Or it can give you positive K or negative K. That will depend, right? So if you move from I to J, see, it will give you positive K. I is along x-axis, y-axis, and z-axis, right? So I to J, it will give you K. Okay. So you can do this for all the axes, but the result is very simple, and you can summarize it in this diagram. You can remember all the results that you obtain from this diagram. Okay. So if you have I cross J will give you K. Okay. J cross K will give you I. Okay. So if you are going in cyclic order, basically the answers that you get will be positive. Here if you see K to I cyclic order, right? Cyclic order. So in this order which is shown. Okay. So K cross I will be J. Okay, so if you are going anti-clockwise, so if you are going clockwise, the answers will be positive. If you are going anti-clockwise, the answers will be negative. Like in this case, I to K, right? This is anti-clockwise. Anti-clockwise, answer will be minus J. It will be J, but minus sign. Okay, so you can also see I cross J is K, and what is that? Okay. K cross I is J and I cross K is minus J. A cross B is minus B cross A. Okay, so you can also see that from here. Okay, J cross I, again if you see, we are going in the anti-clockwise direction, so it will give K but negative K. Okay, so if you go along clockwise direction, it will just give you the next one. So I to J will give you K, so I cross J will give you K, J cross K will give you I, and K cross I will give you J. But if you are going anti-clockwise, K to J, then it will give you minus I. Okay, K to J will be minus I. K cross J will be minus I. Okay, and similarly J to I will be minus K, and I to K will be minus J. Okay, so that's about the different cross product of I, J, K. Let's come to the third property. This cross product is also distributive. You might use it in maths, you won't use it in physics. So A cross B plus C, you can split it, A cross B plus A cross C. Okay, and if you have the vectors in component form, this is a problem that we are going to do next. So if you have it in component form, you can easily obtain the cross product by taking the determinant. The first column should be I, J, K, and then you place the components Ax, Ay, Az, Bx, By, Bz. Okay, component of vector A, component of vector B. These are scalars, right? And these are the vector components. Okay, this will give you A cross B. Okay, so we'll solve a problem on this and we'll end the class. Here is the final question for the day. Here we are given vector A and B in component form. We are supposed to tell the unit normal to A and B. Okay, so how does cross product come into this picture? Here the important word is normal. You can recollect that the cross product of a vector is also a vector which is perpendicular to both the vectors, right? So cross product of A and B is suppose a vector C which is perpendicular to both A and B. Okay, so here we are supposed to find a normal to both A and B. So that is how cross product is coming into picture. Okay, so if you do A cross B, that will give us some vector C which is perpendicular to both. Okay, and then we have to make it of unit magnitude. Okay, that is the later part. So first of all, let us find a vector which is normal to both A and B. Okay, and then we'll make the magnitude unit. Okay, so how do you find A cross B? It's very simple. You write I, J, K. Okay, and the components of A over here 2, 3 and 1. Here it is 1, minus 1 and 1. Okay, I hope you know to open this up. Okay, this is a determinant bracket. It's very simple. So plus minus plus, you put like this. Okay, plus minus plus, and this is how you open it. So first go to I cap. Okay, and then you'll cross out this. Okay, when you are considering I cap, you'll cross out this. Okay, and then you'll multiply this with this. Okay, 3 ones are 3, minus sign in between, and this you'll have to multiply. So minus 1 into 1, minus 1. So this sign will become plus. Okay, now let's do that again. Now minus sign. Okay, for I cap it is plus, for J cap it is minus, and then okay, for J cap we'll cross out this. Right, we'll cross out this and this. So this and this will cross out. So 2 ones are 2, minus sign in between, and this we have to multiply. 1 into 1 is 1. Okay, plus K cap, positive for K cap, and now cross out this and this. Okay, 2 into minus 1 is minus 2, minus sign in between, and 3 into 1, 3. Okay, just open this up. This will be 4 I cap. This will be 1. So this is minus J cap. This will be minus 5. So minus 5 K cap. Okay. So this is our vector C, which is normal to both A and B. But the question does not end over here. It has asked for unit normal. Okay. So in the beginning of the class, when we were discussing about the kinds of vector, I had told you the formula for unit vector. How do you find the unit vector? Okay, if you remember, it was A cap is, yes, you can recollect. So it's vector A divided by magnitude of A. Okay, so it's so if you want to find unit normal, this is a normal, right? This is normal. If you want to find unit normal, you have to take this vector and divide it by its magnitude. Okay, now both the terms have meaning for you. This is this vector itself, and the magnitude. How do you find the magnitude of C? Okay, just when it is in component form, you just add the squares of the component. 4 square 16 plus 1, okay, minus 1 square 1, minus 5 square which is 25. Okay, so 25 plus 16, 31, 42. I think yes, 31, 41, 42. Yes. So basically your unit vector, or this will be unit normal. So C is a normal, and C cap will be the unit normal, which is the vector divided by its magnitude. 4 I cap minus J cap minus 5 K cap by 42, root 42. Okay, so this is the answer that we were supposed to find. Okay, so yeah, that's about it. I think you understood this now. Okay, so that's all that we had to discuss about vectors. Okay, so with that we'll end today's class. I hope you enjoyed it. If you did enjoy it, smash that like button, consider subscribing. I'll be more consistent now onwards. Okay, so before this in November we had our exams, okay, left and right, so I didn't get much time to record videos and put them and upload them, so that is why I was inconsistent. But in December we are going to chase all the things that we were supposed to. So yeah, that is what I wanted to say. That is why I was not uploading. So I'll upload frequently now. Okay, so that's about it. I hope you enjoyed this class. I'll see you soon in the next one. Till then, keep enjoying physics.